Alright, so this is number 99 on the practice exam for CP. Question states, at STP, how many liters of a gas are in 1 mole? So one of the variables we know already is that we got 1 mole. Okay? What we need to know are what standard temperature and what standard pressure, because that's what STP stands for, standard temperature and standard pressure. So for that, you're going to go to your test references if you don't already have it memorized. It's really pretty easy. That its standard temperature is 0.00 degrees C, and standard pressure is 1.00 atmospheres. All right. Now, well, it won't matter because we're going to round off 3 digits at the end anyway, right? Okay. 0 degrees C needs to be changed into Kelvin because we can't use degrees C for gas law problems. And 0 degrees C is 273.15 Kelvin. All right? Not really. No, because the final exam is all multiple choice. All you got to do is figure out the right answer. So, since we have N, T, and P, and we always have R, okay, then this is an ideal gas law problem because we're trying to find V. Okay? PV equals nRT is the ideal gas law. Now, if you didn't remember that, you could look on your test references back here, and you'd find PV equals nRT right here above my thumb. Okay, now which version of R do we use? Which version of R do we use, guys? Okay, the one that matches the pressure unit of ATM. In this case, I chose atmospheres, and because it's easier. Okay, and so we're going to use this version right here. My pen's pointing to of R, of the ideal gas constant or the universal gas constant. All right, so we have all the pieces we need now to plug it into the ideal gas law. Okay, we're just trying to find V. So pressure, 1 atmosphere. I really should have turned my paper sideways. I may not be able to get it all squeezed in here. Times volume we don't know. N is 1 mole. R is going to be 0.08206 liters times atmospheres over Kelvin times moles. And temperature is 273.15 K. So I'm running out of paper over here. So I'm going to transfer this problem to a piece of paper I'm turning sideways. Okay? So I can get all my isolation step done. Alright, I want to be able to get rid of atmospheres. And to get rid of atmospheres on this side, I need to multiply by the reciprocal of this. Okay, and if I do it to this side, I got to do it to this side. Alright, and that's going to get rid of all of this over here. And it's going to leave me with volume, and that's what I'm trying to find in the problem. On the other side, I can now simplify. I left off K here. I need the units of Kelvin there. So moles cancel. Kelvin cancels. Atmospheres cancel. The only unit I have left is liters, and liters is a measurement of volume, so I know I've probably set everything up right. All I have to do now is to do all the math to find the answer.
I like this problem.
Uh-oh, this calculator's battery's dead, I guess. Oh, you got it already? So V equals what? 26? Does anybody else plug it in their calculator? Nope. What? You got a different answer? Only 2 people are putting it in the calculator? Alright, so 0.08206 times 273.15 is all you have to do, right? Because everything else are ones. Correct? Did you get the same thing Breezy got? 22.414. Okay. And then listen, this is the time to find that out. It reminds you right before the exam to do your math twice, right? 22.414 what? 689. Okay, and that's liters. We round that to how many digits? 3. So from this 1 right here over, all those are going to be gone. And so we have 22.4 liters. Okay? And it turns out that's an important value to know. Because, listen carefully, at standard temperature and pressure, 1 mole of gas is equal to 22.4 liters of a gas. That's called molar volume. At standard temperature and pressure, 1 mole of gas equals 22.4 liters of gas. Okay, and that's called molar volume. This is molar volume. What? We've gone over that before. We talked about it before. Oh, we may have done the problem, not have. Okay?